Section 32. This one's kind of a mouthful. It's exponentials whose bases aren't e. So we're not doing e to the x, we're doing like 5 to the x. And we're not doing natural log, we're doing log base 10 or log base 7 or log base 5. Alright, all you do for this is rewrite, then do the integral of natural log or e to the x. So we're going to rewrite these as like e to the x things, and that is how we do these. So let's look at first how we rewrite them. So I have the logarithm change of base formula written here. So when you have log base anything of anything, you can rewrite this as natural log of the base, or natural log of the inside over natural log of the base. So like natural log of A over natural log of B here. In our examples here, natural log of 15 over natural log of 7. Now the derivative of this one would just be 0, because both of those are numbers. But in the case of this guy, it's actually really useful, because we can write this as log base 11 of 3x, got no tricks for that. We can rewrite it as natural log of 3x, the inside, over natural log of 11, our base. And remember, natural log of 11 is like, what would it be? 2.7 to the third is a little bigger than that, so maybe this is 2.7-ish. So really, this is like 1 over 2.7-ish. And it's probably less than that. I don't know. I didn't check it. Times the natural log of 3x. So now it's just a derivative. Derivative of natural log of 3x is 3 over 3x. So it's 1 over 2.7-ish times 3 over 3x. Or I could rewrite this exactly and plug back in natural log of 11 instead of this nonsense. And it's 1 over natural log of 11 times 1 over x. Or 1 over x natural log 11. So really, all we're doing with these different base ones is we need to know the logarithm rule that lets us change the base. Let's check out the exponential tool. So for the exponential one, say you have 5 to the x minus 1. This sucks. If we had it in terms of e, it would suck less. Like we know how to deal with that. Luckily, there is a relatively easy fix for this. If we want to rewrite this as an e to the whatever of, we can remember that, well, if you remember, exponents and logs undo each other if they have the same base. E and natural log have the same base. So e to the natural log of 5 would be equal to 5. So I'm going to rewrite 5 here as e to the natural log of 5. So it's going to be e to the natural log of 5 times x minus 1. Now I can take the integral. So now if I integrate this, dx, I'm going to get, well, I rewrite it, because we always do that when we take the integral of exponentials. And then I multiply by the chain rule, or divide by the chain rule, because it's an integral. So I divide by, well, it's natural log of 5 times x, so the derivative of natural log of 5 times x is natural log of 5. So divided by natural log of 5. Last step, I'm going to turn this nonsense back into 5 to the x minus 1. And it's just 5 to the x minus 1 over natural log of 5 plus c as I run out of space here. Alright, so there is a shortcut here. That was the long way that explains why whenever we take the integral of a exponential function, we divide by the natural log of 5, the base there. So here I did a derivative of natural logs to show how we change the base to get that, and here I did an integral of an exponential to show how we change the base here. We do the same thing for derivatives in either direction. If I took the derivative of this thing, it'd just be natural log of 5 times the exponential. So let's try a few more examples down below. I'm going to show the shortcut in this one. So this is another integral of an exponential sort of situation here. I could, and I'm going to do it, show the shortcutty way here. I could rewrite this as this, and then worry about the integral there. Or I could just say, hey, I know I'm just going to divide by the natural log 2 thing because I've seen this before. You just divide by the natural log at the base. So I'm just going to say, hey, the derivative of this thing is going to be, okay, rewrite the thing. Always do that first. Divide by the natural log of the base, natural log of 2. And technically here, I'd also have to do a u substitution, or because the derivative of this is just 2, I can know that I'd divide by 2 also. And then for the 3 to the x, that one's like way easier. It's just going to be 3 to the x over natural log 3, and then just plus c, and we're done. All right, next. Logs. Logs have the easy rewrites. It's just going to be 2 ln 4x over ln 3, because our base is 3. And here, we're going to have 2 ln 2x over ln 3. So not too shabby there. Now I can take derivatives. So I'm just going to pull out the 2 over ln 3. And the derivative of 4x is 4 over 4x, u prime over u. Derivative of 4x being 4 over 4x. All right, and then here I get 2 over ln 3 times, oh, that's nice. It's just natural log of 2x, 2 over 2x. If you notice, this is 1 over x. That's 1 over x. So these are actually exactly the same, both of these terms. So it turns out the derivative of 2 log base 3 of 4x and 2 log base 3 of 2x is not the same. Oh, yeah, I did that forgetting thing. Where you forget to do the chain rule. No, I didn't. I did the chain rule. No, we're good. This is right. All right, so 2 over x ln 3 plus 2 over x ln 3 is just 4 over x ln 3. And I've done it. Without blowing my mind there for a second. All right, so these are pretty easy. The change of base thing is just really not a huge leap. It's do a little bit of algebra, then do your calculus. Or in the case of exponentials, know the shortcut because it's a lot easier to do the shortcut than doing this thing. Okay, before I end the video, I wanted to do a few examples of going the other direction because I did exponentials or integrals for exponentials both times. Let's take the derivative of e to the 3x squared, or wait, not e. Let's do 5. No, 5's too useful. 4. 4 to the 3x squared minus 1. If I take the derivative of this, easy. 4 to the 3x squared minus 1 times the chain rule, 6x, times the natural log of the base, natural log of 4. So here I divided by the natural log because I integrated, just like I kind of divide by the chain rule kind of when I integrate. And when you take the derivative, you just multiply by the chain rule, multiply by the natural log of the base. Easy. Turns out integrals of natural logs are not something we're really going to worry about right now. And that is it.